All right. There were build errors. And it says it doesn't know what to do with the dispose method. And the reason that it says that is because I haven't written a dispose object. Well, not a problem. What I do is I go over here to, let me spread this apart a little so you can see it. This file is the designer.cs file. It is one of those files that Microsoft Windows writes for you. I'm going to delete it. Okay? Now, because I deleted it, the project doesn't know where to begin. That was held in that project file. So I go over here and I go down to the sample project properties. And you'll see here it says startup object. I want that to be my form main. This says what the target framework is. I want this to run in a net environment using the Windows properties. I'm going to have it run as a Windows application. You can also have it be a console application, or you can write standalone class libraries if you wish, but most of the time you're going to be using a Windows application. Okay, and we can dismiss this now because the program now knows where to start up. And there's my program so far. So we have a fully functional program using object-oriented technologies, drawing upon the Windows form and all of the abilities that a Windows form has. And you'll notice without writing any code, I have a minimize button, I have a close button, I have a general shape to the form, I have coloring set, I have subclass capabilities if I wanted to use them. All of that came because of this one little piece of code right there. We are inheriting all of the functionality of a Windows form by simply telling that the form main is going to extend the functionality of a Windows in some way. Now, with that understanding, let's go to the form main and let's look at the visual interface that we saw. It wasn't terribly interesting. This is the form that you saw on the screen just a moment ago. And the first thing that we might want to put on this is a title text that sort of tells what the program's going to do. And I'm saying that this is just going to determine whether we have a leap year or not. I like to use the properties in alphabetical order, just a personal preference. And the Windows Start position, I like to use center screen as the default. If you're writing a multiple document interface, you'd probably want to use center parent. But because this isn't a multiple document interface program, center screen is a good choice. Now when I run the program, the form appears in the center of the screen, whereas before, if you remember, it was stuck over towards the left a little bit. All right. Having done that, the first thing that I want to do is to put a label on this thing to tell people what they want to enter. Now, I have personal preferences about the way I like a program to look. And it is non-standard Windows. So you can ignore this or you can do it depending on your own choice. But I think after you see what I do, you might like it and you might want to adopt it yourself. If not, you don't have to. The first thing that you want to do is look at auto size. By default, Windows and the inherited ability of all of the tools, and in particular the label, they have behaviors that are set in that Windows library. One of them is auto size. I don't like auto sizing because the label expands to the exact size that it takes to print out the label. So I'm going to change that to false. When I do that, you'll notice I get sizing boxes. Those are those little squares that you see, and I can grab those and stretch and shrink the size of the label. By turning auto size off, I get these sizing boxes. If you don't, the sizing boxes just aren't available to you. The other thing that I like to do that is not standard Windows is I like to set the border style. And I liked Fix 3D. And you can see the effect that that gives. It gives sort of a depth to the form that's not there otherwise. And again, this is non-standard. Okay, click on the object. And we're going to change this to, we want this to be the year that we're going to test. So that becomes the narrative inside of the object, the label object. I don't like the way it aligns, so I go down to Text Align, and I change it to be right justified. I also don't like this fact, and this will become clear if I put a text box on here. If you'll notice, the label is wider than the text box. I don't like that. So, if you don't like something, change its property. Now I changed the property of the text object, of the label object from 23 pixels high to 20 pixels high. Obviously then, because I've changed the property of the label object, I've changed its state as well. All right. Now I have a label object. I have a text box object. And about all I need to do with the text box object is give it a name. I prefer to label all of my control objects with a 3-letter prefix. And I use text for text boxes. I use TXT, and I'm going to call it year. So now I have an object, a text box object named TXT year. Next thing we need is a button object. And BTN I use for button, and we'll just say button check. We need to change the text on the button. And that may be not the best choice for a button, but it says, is it a leap year? Yes or no. Then let's put another button object on. And we'll call this one button close. I'm sorry, the name is close. And if I do it this way, you'll notice that close just appears as plain text. If I want to, I can put an ampersand in front of that. And when I do, you'll notice that the letter following the ampersand gets underlined. That becomes the hotkey then, so I can do an Alt-C and use that instead of a mouse if I wish to. Now we'll give it the proper name for the object. Whoops. And now we have our program, or at least we have the visual interface for what this program looks like. And you can change the form. And that's the basis of our program. What we need now, we have, in essence, an initialization step. Remember the 5 program steps? That's going to go back, and you'll notice behind your back, Visual Studio added all of the initialization code that sets what the labels and the text boxes and the buttons and so forth do behind your back. And by clicking on that region button, I can get rid of all that clutter because I don't really need to see it. I didn't write the code. Chances are it's correct because I didn't write it. I mean, I make mistakes too, but that code's going to be solid, so I don't need to look at it. Now I've got more real estate to look at the code that I really am interested in. So in the design sense now, I have everything, but I might want to add one more component to this that gives me the ability to say something if I am a leap year or not. So let's take a label object and throw it on in the middle here. And I'm going to turn the auto size off again. so that I can size it. And I'm going to stretch it. Oops. And I'll center the text. That means centering it. And now the label, for all intent and purposes, is invisible. All right, what we've done here is we've designed a program. If we look at the code, this becomes step 1. We're initializing the components. Step 2 is going to get the information about what year it is that we want to check. So really, filling in this text box with a year is going to be the input step. We're going to collect a year date there. Then we're going to click on the leap year check button, and that's going to tell us how we're going to process that year to find out if it is or is not a leap year. Then we're going to use this label for the output phase, and we're going to write this is a leap year or it isn't a leap year. And then the close button becomes the termination step. That's just going to, because we didn't really have to do anything, we're just going to close this particular program. So to do that, I can double click on the close button, and it will write the stub code necessary to process a button close click event. And all I have to type here then is close. And because I didn't have to do anything tricky, this should work just fine. All of the initialization stuff was written by Windows. When I do a close, the Windows garbage collector collects all the resources and disposes of them in a nice way. So when I run this, I can type something in, I can click close, and the program ends. So we're okay so far. Now what I don't have is I don't have any class code yet. And that's the next task. We've got to write the code that is going to process what this class does. So what we want to do now is add the code for the class that's going to do the date calculation. To do that, go over to the project, and you'll see this option that says to add a class. So we click on that, and a box comes up. And like I said, I prefer to call my classes with a class lead-in of CLS, and we'll call this dates. And we'll say add, and you'll notice it appears in my Solution Explorer list of things that we're going to be using in this program. Now again, when I did that, behind my back, Microsoft wrote all of this code. We don't need that code. And in fact, to make this more specific to whatever you're using as a language, a development language, we can actually get rid of that. We always need the system object, however. And now we're going to write the code that is going to tell us how we want to define this particular object. So we do now, there is no etched in stone form or pattern that you must use when you write a new class. You're free to do that yourself. But I think it's a good idea, especially if you're writing in an environment where there's more than one programmer, I think it's useful to adopt a form for classes that everyone shares. It'll make it easier to share code. Comments, of course, in most language, well, many languages are introduced with double slashes, so I'll do this. And what I'm doing is saying, okay, what follows are a list of those properties that are going to be pertinent to this particular class. And I'm going to have one that's called return flag. I'll have another one called int day. I'll have another one called int month. I'll have one called int year. And I'll have one called int had the cursor in the way. Called int leap year. So these become the properties that I want this class to have right now. This list can change. I can add or even delete properties as I see fit during the course of the program development. Now, something else that I'm going to do is I'm going to create another data item, and the two open and closed brackets following a type specifier like you see right here signifies that we're about to define an array. And what I'm going to define, let's leave that as a lowercase o. What I'm going to define is the number of days that are in a month, and I'm going to make it, because arrays are objects, we use the word new to say we're going to instantiate a new array object of type integer. And if I start with a bracket, that means I'm going to supply an initializer list for this array. So I'm going to put in 0. Let me see where I am. January, February, March, April, May, June, July, August, September, October, November, December. Now, a legitimate question for you to ask is, it looks like it's in overstrike mode. Okay. Why did I put 0 at the beginning? The reason that I do that is because if I ask you what's the first month of the year, most people don't say February. But in array terminology, since they're 0-based, the first month would actually be, this is the 0th month, this is the first month. If I started this with 31, the first month moves to 28, and February becomes the first month. Oh, I just noticed that I had to change this from 31 to 30. I forgot the old poem. But anyway, what I've done here is I've started it with the 0 month being 0 and the first month being January, the second month being February, because that's the way people think. And don't forget, if I write this class in a useful fashion, I'll be able to use it in some other program. In other words, I should be able to take class dates, pull it from here, put it into another program, and someone should be able to use it. Since it's going to be another programmer, and they want to pass in the first month, it's not going to be the 0th element, it's going to be actually the second, because that becomes, when you're using 0-based arrays, that becomes the first month. Now, why did I use the term static? Static is a storage specifier. It tells how this particular piece of information is going to be stored. You'll notice these properties up here, none of them use the static storage class. And there's a reason for that. When you use the word static in a program, that tells the compiler that I'm only going to generate one of these. I don't care if you instantiate 300 variables of class date. I'm only going to create one days in the month array. And it makes sense because really days in the month is almost a read-only piece of information. I'm only using it in this particular program to determine the number of days in each month. There's no reason then for duplicating this array for every instance of this class that's created. They can all share this data. Now, there's a couple of other important things about this. This particular variable then, because it has the keyword static in front of it, will always get created at the time that this program is loaded into memory. So the burden of this then is, yes, I only get one copy of it no matter what, but the other side of that coin is, yes, I only get one copy of it, but I always get one copy of it. So even if I never plan on using days in the month, that's going to take up memory space. So you can think of it as I'm wasting 52 bytes of storage, perhaps, but with a mega munch of memory in most machines these days, I'm not too worried about it. The other thing that I'm going to put in here is a date, time, object called myDate. Date time is one of the cookie cutters that Windows makes available to you and is an integral part of the system itself, the programming system. All right, that's my property list. My property list is complete as far as I want to take it at this point. I can add to it later, which I will be doing, but for now, that's all I need. So the property list is done, but I don't have a constructor. So I really should write a constructor. Now, by default, and we covered this earlier, any object-oriented programming language will create a default constructor behind your back with no code visible in the program anywhere. And the purpose of the default constructor is simply to initialize the data lists of properties to an appropriate initial value. In this case, all of these integer variables are going to get set to 0. Because we have to make the constructor visible everywhere throughout the program, we're going to use the public access specifier. It becomes part of the user interface for this particular piece of code. And it's for the class date object. And since it's a method, it needs open and closing parentheses. And all I'm going to do in here is set myDate equals date time now. What that does is it sets the myDate object to hold the current date and time as it's stored on the system's internal clock. And that becomes my simple constructor. What I've done with this simple constructor is I've overridden the default constructor that would set all of the other variables to either 0 or null. In the case of the static array, all of those values will be set to 0. But there may come a time when that's not what I want to do. I may want to have a constructor that does something different than just simply initialize all of the variables to the current date and time. There is nothing that prevents you from writing multiple constructors. So we can do that. The only difference is if we write multiple constructors, we have a situation where we are overloading a method. Overloading is just simply a fancy way of saying we're going to have more than one. If that's the case, the signature of all of the constructors must be different. Well, since we're using public and class dates in all of them, the only place the signatures can be different is the parameters that we pass into it. So our first constructor has no parameters passed into it. At least we have to pass something into this constructor to make this work. So in this case, we're going to pass in something called int year to use. So now we have two constructors, and we say that The second one is the overloaded constructor because it does have a signature that requires us to pass in a parameter. Now, what we're going to do in this second one is we're going to say year equals year to use. In other words, what this does is it takes the year up here, that is our property, as it's been passed to the constructor, we take the value passed in and assign it into that particular property. Now, as this code stands right now, this is not a good way to write this constructor. And the reason is, think about it. If I call class dates with no parameters, what happens? This line says that month, day, and year all get filled in with the current date and time of the system clock. On the other hand, if I use this constructor that does pass in a parameter, now I have year set. It was set up here when we called now. But now, what's the state of day and month? In this second call, day and month are 0, whereas up here, day and month have been initialized to whatever the system clock says they should be. That's not good, because now you've got one method, a constructor, that takes different arguments that leaves this object in two different states. That's usually never a good idea. So, how do I solve this problem? How can I call this second overloaded constructor but still make sure that I set the day and the month at the same time? Well, one way would to be by hand duplicate this particular piece of code here, put it in front of this line down here, and that would set the day, month, and year, and then this line would overwrite the year to be whatever we passed in. But that's more code than we need to write because we're duplicating exactly what this code does. Well, to solve that problem, we can do this. What that says is call this constructor with no parameters and then execute this line of code.